Welcome back to Tech Nuggets. In this video, I'm going to show you one of the best open source model from Google. Yes, you heard it right, Gemma3. We are going to install and experience locally using Ollama and Open WebUI. Okay, first of all, what is Gemma3? As I mentioned, it's a latest release of open source model from Google. And it is multilingual. Yes, it supports 140 languages. And it is multimodal model. Yes, it supports text and images, and it supports long context length up to 128K, and it has a better agentic capabilities. Okay, let us see some more details of Gemma3. First of all, it's a lightweight, and it is available in 1 billion, 4 billion, and 12 billion and 27 billion parameters. And if you look at the evaluation chatbot arena score, Gemma 3 27 billion is comparable to DeepSeek V3, and it goes much closer to DeepSeek R1. Okay, some of the benchmark result between Gemma 3 1 billion, 4 billion, 12 billion, and 27 billion, and uh, the the larger the model, the performance benchmarking is higher. However, you can straight away get started with 1 billion for your programming needs. Okay, and you can see this multilingual capabilities starting with 1 billion, 4 billion, and 12 billion, 27 billion, right? Then multimodal capabilities, again, the bigger the model, the perform better the performance benchmarking. You can see that. Okay, you can see more details in Ollama website or Hugging Face documentation site. Okay, what is the demo agenda? So we are going to install Ollama, download Gemma3, and set up Open WebUI client using Docker setup and run the test prompts. Let's get started. First step for the demo, we need Ollama running locally. Let's go to ollama.com and click download. Based on your operating system, it will detect, and you click on the download button and follow the instruction so that you will get started with Ollama installation. After the Ollama installation, we need to run through some of the commands. So the first command will be, we need to pull Gemma3 model locally. So you'll be using Ollama pull command. That is, we are going to use 4 billion model. My system configuration is it has got a 4 GB graphics card, NVIDIA RTX. Then the next step is going to go to open WebUI URL using this GitHub, and we are going to run the Docker command. If the if your Ollama server is running on the same system, you will be running the first command. If it is on a different server, you will be running on the second command by replacing Ollama base URL. Okay, let us see the system configuration. That is NVIDIA SMI. Yes, you can see that it's a 4 GB graphics card, and this is a 8 CPU with a 16 GB system. Okay, so the next step will be Ollama pull Gemma3 4B version. I already ran this command, so the version is available. We can check with Ollama list. You can see that Gemma3 4B. You don't need to run this because you are going to access this from Open WebUI. So next step, let's go to Open WebUI GitHub page. Let's find a command for Ollama installation. That is your okay. You go here and you see this Ollama on your system. That's on the same system. So let's pick this command. We'll run it from the command line. So this is the command to create a Docker container, and it will be running on port it will be exposed via port 3000. Internal it will be 8080, it will be mapped to 3000. Okay, it will take the latest open WebUI image and it will be running. So I already ran this command, my container is running. I'll show that. So in order to do this, your prerequisite will be Docker desktop. So make sure that you install and set it up. So Docker ES, you can see open WebUI is running on port 3000. Okay, so once open in the URL in the browser, that's localhost 3000, you get the screen. You need to sign in, even though it's running in locally, you need to register with your email and password. It can be anything. Give your email and password. It's not going to be on the internet, it will be locally saved. Okay, I have registered with my email ID and password. Let me sign in. Perfect. So now we are able to log in. I can see this Gemma3 4B as a model selected. Awesome. So we have set our setup is over. One of the plus point of using open WebUI is you can use this interface. It's a feature rich interface. You can use this UI to interact with any model. For example, you can select the model you wanted to chat with. So for this a demo purpose, we'll be having a Gemma3 and we will get started with our prompt. Okay, let's start with our first test prompt. We wanted to check Gemma3's counterfactual reasoning and historical analysis. Let's go ahead and put the prompt. The prompt is, if the library of Alexandria had not been destroyed, how might be the trajectory of scientific and technological advancement have differed? Provide your detailed analysis of potential alternative timelines. And also you can see there are some suggestions. We are not going to use that. Let's go ahead and run this. Perfect. You get an instant response. Let's wait for a few seconds to complete the response and I'll read it. Okay, let's go ahead and test Gemma3. Here we go with our first test prompt. That's we wanted to check Gemma3's counterfactual reasoning and historical analysis. The prompt is, if the library of Alexandria had not been destroyed, how might the trajectory of scientific and technological advancements have differed? Provide a top 5 summary level analysis and potential alternative timelines. And also you can see there are suggestions by Open WebUI. We are not going to use it. Let's go ahead and put the comment, put our prompt. You can see the instant response and it immediately recognizes there is a what if scenario. And here we go with the top 5 summary level analysis. It completed the response. You can see top 5 summary level analysis. That's accelerated knowledge transmission, continued Greek dominance, early Renaissance influence, delayed technological revolutions, altered geopolitical landscape. Awesome. And also you can see there's a potential alternative timeline simplified. One is a timeline 1 with a continuous Hellenistic, that is first BC to 1500 AD, that is first to 6th century, 7th to 11th century, very detailed. And timeline 2, Alexandrian Empire, it talks about 1st century BC to 1000 AD. Then timeline 3, the fragmented legacy, 1000 AD to present. Very good. Okay, you can see up to 20th century to present. Very important caveats. Butterfly effect, small changes in the past can have enormous unpredictable consequences. Other factors, this analysis focuses solely on the library survival. Other factors, political instability, economic conditions, religious movements would still have played a crucial role. And human agency, the people who have accessed and used the library knowledge would have made their own choices, potentially leading to different outcomes. The analysis very good, excellent. And also it continues with this conversation with a few more questions. The potential impact on particular scientific field. Would you like to continue with multiple other detailed things? Very nice. This conversation with a few more questions. The potential impact on particular scientific field. Would you like to continue with multiple other detailed things? Very nice. So let us see the performance stats. So with this configuration with 4 GB GPU with 16 GB CPU, RAM with 8 CPU, the response tokens is 8 tokens per second. Not really bad, it's really good. And a duration taken somewhere around 2 minutes because of number of tokens. The tokens were somewhere around 1050. Perfect. Okay, let us test Gemma3's geometry and area perimeter math problem ability. Let's go ahead and put a rectangular garden as length, that is twice its width. The perimeter of the garden is 60 meters. What is the area of the garden?
A few moments later.
Okay, it took some time to respond. Now it's broken down this math problem into step by step, and so you can see the response. Let W is a width and L is the length of garden. As we know, the length will be 2W, that is the length is twice the width. The perimeter is 60 meters. Formula for the perimeter of rectangle is P equal to 2L plus 2W. Okay, now we can set up the equation using perimeter information, that is 60 equal to 2L plus 2W. Substitute L equal to 2W in equation, that is 60. You can see that 2 of 2W plus 2W, that's 4W plus, it arrives at 6, and solve 60 by 6. It will become, width will become 10 meters, then the length will be L equal to 2 into W, that is 20 meters. The area is finally, it arrives at 200 square meters. Very good. It breaks down this math problem into step by step, and it provides a very nice uh, math step by steps solving ability. Overall, the model performance is really good. I like the ability and the explanation and the response and the detailing. Okay, so feel free to play around this model and explore it. If you like this video, please share it, comment it, and subscribe it. I will have a follow-up video with vision capability. I'll see you in next video. Thank you.